Hi guys, welcome back to this channel. If you are new to this channel guys, please do click the subscribe button and notification bell so that you'll get notified on our future videos just like this one. So in this video guys, ang topic natin is simple stresses. This is part of strength of materials or sa mga mechanical engineering dyan, this can be included in your machine design. So simple stress are the start of your foundation in machine design and strength of materials. So let's solve problems regarding simple stresses. I-explain ko sa inyo yung mga types of stresses that are involved in materials. So let's solve some sample problems.
So when we say stress, it is the force per unit of area. So S is equal to F over A. Okay? Then, meron tayong mga types of stresses. Ang types of stresses natin guys is nakadepende siya sa area under stress. Okay? So for example, meron tayo ditong cylindrical member siya. Then we apply a force here. So this is F. The area under contact is this area here. So as we can see, ang area na to is perpendicular to this force here. So this is the area under stress. Now if the force is perpendicular to the area, that's what we call a normal stress. Okay, normal stress. So normal stress, meron tayong dalawang klase niyan. It's either tensile stress. So tensile stress if the force is going away. Okay, that is going away from the area. So for example here, it tends to lengthen this member. So going away from the area, that is tensile stress. So when the force is actually going in to the area, so the area pa rin guys is perpendicular to the force here. So this is A. This is our member, cylindrical member. If the force is going in to your area, this is what you call the compressive stress. Okay, compressive stress. In this particular video guys, we are going to discuss about the normal stress. We have here the two types, the tensile stress and the compressive stress. Then we are going to define another types of stress, which is what you call the shear stress. Ano naman ang pagkakaiba ng shear stress sa tensile stress and compressive stress? So ang tensile stress and compressive stress, ang pagkakaiba lang nilang dalawa is the orientation of the force. Okay, the orientation or the direction of the force, but the area is still perpendicular. Now if you are dealing with shear stress, if this is your force here, okay, this is the force. So notice that the force here is actually parallel naman siya, parallel to the force. Okay, yung area under contact. In this case, if the area is parallel to the force, inline siya sa force, this is what you call the shear stress. So the type of stress actually depends on the orientation of the area under contact. So let's solve sample problems to further explain these concepts. So what is the maximum allowable load that can be carried by a 5-inch edge cubical member if the allowable compressive stress is 2000 psi? So let's draw the figure. So siya ay cubical member, so equal yung edges niya, cube. Then the force must be compressive because ang given natin dito is a compressive stress. Okay, this is the force here, compressive. So F, this is the area, shaded area under contact. So that is an area of a square. Okay, so stress is equal to force divided by area. So hinanap natin dito is the maximum allowable load. Therefore F is equal to SA. So S natin, so F is equal to S. S natin here is 2000 psi, or that is 2000 pound force per square inch. Okay, psi times the area. So the area under contact natin dito is actually area of a square. So we just square the side. So this is 5 inch, so squared. So this is equal to 50,000 pound force. So this is the maximum. Ito na guys yung maximum allowable load that can be carried by this cubical member. Ito na yung ating final answer. So let's proceed to our next problem. So in this next problem guys, we have here an iron column of annular cross section has an outside diameter of 200 millimeters and is subjected to a force of 75 kilonewtons. Find the thickness of the wall if the allowable compressive stress is 10 megapascal. So sa problem na to, we have here annular cross section, outside diameter. Ang hinahanap natin guys is thickness. Therefore, this is actually a hollow. Okay, hollow cylinder siya, meaning hindi siya buo yung volume niya sa gitna. This looks like this figure looks like this. So hollow cylinder siya kasi meron siyang thickness. Okay? Then yung force natin is a compressive force. We have here. So this is 75 kilonewtons. Okay? Ang hinahanap natin dito guys is this thickness, T. The thickness of this iron column. So the outside diameter, okay, itong outside diameter niya, DO, okay, DO is equal to 200 mm. Ang DO niya. So i-project natin yung top view niya. So we have this. Okay, ito yung top view niya. So if this is thickness, so imagine nyo guys na perfect circle yan, no? So this is T, this is your thickness here. Dalawa yung thickness, magkabilaan. Then this is actually your outside diameter. Okay? So if this is your inside diameter here, so this is DI. Therefore, from this geometry, we can say that DO is equal to DI. Okay, DI plus dalawang T. So, plus 2T. Okay, therefore, the thickness is actually equal to DO minus DI all over 2. Okay, we just do that algebra. So, the stress is equal to, we have here force all over area. Okay, as you can see here in the figure, ang area under contact is ito lang, itong naka-shade. Okay, kasi ito, this is an empty space. Itong naka-shade lang yung kanyang area. So, ano yung area nun? Okay, so area ng malaking circle, okay, minus area ng maliit sa loob. Okay, so we have here, area is equal to the area of the bigger circle minus the area of the smaller circle. So, yung area ng bigger circle is pi DO squared all over 4. That is an area of the circle minus yung area, i-minus natin yung area since na empty space siya, yung area of the smaller circle sa gitna. So you have here pi DI squared all over 4. Okay? So in order to find the thickness, kailangan nating mahanap muna yung inside diameter. Okay? We have here, given kasi yung DO, DI lang yung wala. So we can say we have here pi all over 4. I-factor out na natin siya, DO squared minus DI squared. Ito na yung input natin. So we have here, stress is equal to force all over area. So area is equal to, we have here force divided by stress. So area natin, this is pi over 4 times the quantity DO squared minus DI squared is equal to F over S. Okay? F over S. Wherein, ang ating DO, given tayo ng DO, outside diameter. Outside diameter natin, that is 200. Okay? 200 millimeters. This is pi all over 4 times 200 mm. So, this is squared. Minus DI squared is equal to F. F natin, guys, from the problem, that is 75 kilonewtons. Then, yung ating maximum allowable stress is given by 10 megapascal. Okay? So, you can see here in our solution, hindi consistent yung unit natin. So, do not input that in your calculator automatic. Okay? Kasi kailangan pa natin siyang i-convert. So, i-convert muna natin, guys, yung mm to meters. So, we have here, so, i-convert muna natin lahat para consistent yung unit natin. So, we have this pi over 4, okay, times the quantity we have here, 200 mm. So, yung 200 mm, gawin natin siyang meter muna. So, times, we have here 1 meter. So, this is 1,000 millimeter. So, squared minus DI squared. So, this is equal to, so 75 kilonewtons, i-convert natin siya to newtons. Okay, so 75 kilonewtons times. Ang kilonewtons natin guys this is just 1,000. So you have here 1,000 newtons. So this is 1 kilonewton all over. 10 megapascal. So convert natin to pascal. So we have this 1 times 10 raised to 6. This is pascal. So this is 1 megapascal. So mega means million. So i-simplify natin. So you have here pi all over 4 times the quantity. So 200 divided by 1,000. So this is 0.2 meters na siya. So squared minus di squared is equal to, you have here, so 75 times 1,000. So this is 75,000 newtons. Okay, so this becomes, so 10 times 10 raised to 6. So this is pascal. So itong pascal guys, pwede natin siyang palitan as, we have here 75,000 newton. So equivalent unit ng pascal is newton per square meter. So this is 10 times 10 raised to 6 newtons per square meter. So i-simplify lang natin, this becomes, so we have here pi all over 4, so 0.2 meters, so squared minus di squared equals, so i-simplify natin to. So yung unit nito guys is square meter na siya. So this is 7.5 times 10 raised to negative 3 square meter. So newton here will cancel out. Then i-divide natin both sides by pi over 4 to cancel this out. So this becomes 0.2, so quantity, you have here squared minus di squared is equal to, so 7.5 times 10 raised to negative 3 square meter divided by pi all over 4. Then we just do algebra to find di squared. So di squared is equal to, so ilipat natin sa kabila, then ito magiging negative. So we have here 0.2 meters quantity squared minus, so you have here 7.5 times 10 raised to negative 3 square meter divided by pi all over 4. Then to cancel this square here, just get the square root of both sides. So this becomes di equals, so just input this in our calculator. So yung unit na guys is naka meters na since square root of square meter. So this is equal to 0.1745 meters. So hindi ito hinahanap natin. So we are finding here the thickness
From the geometry of the figure, so this is a hollow column. So if this is your thickness T here, then this is your inside diameter, this is the outside diameter. Therefore DO is equal to T plus DI plus T, or DI plus twice nung thickness. So therefore T is equal to DO minus DI all over 2. So from the problem guys, the outside diameter is equal to 200 millimeters, so that is equal to 0.2 meter. Then input that here, so thickness is equal to 0.2 meter minus 0.1745 meter divided by 2. So thickness is equal to 0.01275, that is meters. Then we convert this to millimeter. So this is 1000 mm per 1 meter. So cancel na yung meter. Ang unit natin is millimeters. So thickness is equal to 12.75 millimeter. So the analysis here is that this is the minimum thickness, so that this column can withstand a force of, or a load of 75 kilonewtons. Ang material natin, ang kanyang property, it can withstand a stress of 10 megapascal. This is the maximum compressive stress. Therefore, if the thickness is less than this, probably the material will actually fail. That's why it is important in the study of strength of materials and machine design.
So in this next problem, what force is required to punch at 20 mm diameter hole in a plate that is 25 mm thick. The shear strength is 350 meganewtons per square meter, or this is megapascal. Now, let's draw the figure. So, ito yung plate natin. Ang thickness ng plate natin is 25 mm. So, the thickness of this is, itong thickness niya, here. Ito, this is 25 millimeters. Then, a 20 mm diameter is punch. Okay, pinunch natin siya. For example, ito yung puncher natin. So, if you imagine this, puncher siya. Ipapunch natin yung, so wala siyang area sa gitna, no? So this is just hollow. So pag pinunch natin siya dito, so mabubutas siya. Okay? So this becomes like this, the final product natin. So butas na yan dyan. So makikita natin, we have this. So nabutas na yung ating plate. Okay? So if this is our force here, okay, as you can see here in the figure, if you punch it here, nabutas siya, yung ating area is actually na-apply dito sa mga gilid, itong mga gilid niya, yung ating parallel area. So in this case, this is actually a shear stress, because if this is your force here, the area, so this area under stress, yung nasa gilid, okay, kung imagine niyo yan, yan ang nabutas na nasa gilid, so yung area of that is actually parallel to the force. This is a shear stress. Okay? So, shear stress is equal to force over area pa rin. Okay, so what about the area? So, yung stress natin is given. That is 300. So, 350 megapascal. Okay, that is meganewtons per square meter. So, the force is equal to S times A. So, yung S natin is 350, so megapascal. So this is meganewtons per square meter times the area. Ano ba yung area natin? Area under contact. So the area under stress, okay, yung area nitong bilog na to, yung nasa gilid, is the circumference times itong thickness niya, the thickness of the plate. Okay, i-project natin yan. Project natin siya. Gawin natin single strip. Okay, putulin natin dito, here, and ilatag natin siya, magiging parang ganito siya. Okay, so the area of this, i-roll lang natin siya dito. This is your circumference, that is pi d. Okay, and this is your thickness. Kinuha natin siya doon sa loob yung area under stress. So circumference times the thickness. So circumference natin is pi d. So this is pi dt. So the area here is pi dt. So i-input natin siya. So force is equal to stress, 350 meganewtons per square meter. Then yung ating area under stress is pi times d. Diameter natin, ilan ba yung diameter from the problem? Given tayo sa problem ng diameter, that is 20 mm. So we can see here 20 millimeters. So this is 20 mm times thickness. Thickness is 25 mm. So force natin here is equal to 350. You have here meganewtons per square meter times pi. Okay? So itong dalawa, this is, ang unit niya is mm squared. So 20 times 25, this is 500. Okay? So this is 500 millimeter squared. So i-convert natin itong millimeter squared to meter, since na hindi siya mag-cancel dito if it is still in millimeters. So this is 1 meter per 1,000 mm. So since naka-square siya, i-square din natin yung conversion. So F is equal to, so this is equal to 0. You have here 0.55497. So approximately 0.55 mega newtons. So this is our final answer. Okay? Kung i-convert natin siya to kilo, okay? convert natin to kilo, pwede natin siyang i-convert. So, this is 1,000. Okay, 1,000 kilonewtons per 1 meganewton. So, F is equal to, so yung conversion natin, i-adjust lang natin yung prefix niya since gagawin natin siyang kilo. So, this becomes, so 1, 2, 3, so this is 550 kilo newtons. So, this is our final answer. So, in this next problem, guys, we have here, find the smallest diameter bolt that can be used in the clevis shown in the figure. If P is equal to 400 kilonewtons, the shearing strength of the bolt is 300 megapascal. So, if you imagine this, guys, if it pushes here, so clevis siya, meron tayong bolt here, ito yung bolt natin. If you actually apply a force here, yung area under stress natin, under shearing stress, is itong nasa gilid, okay? If you imagine this, guys, it can actually fail in this portion. So, using this, so imagine natin na naputol siya dyan. Okay? Let's get the, kunin natin yung portion na yon wherein doon na-apply yung shearing stress. Yung force natin. Ito yung area wherein pwede siyang magkaroon ng shearing stress. Ito, this is the parallel area. Okay, so that is dalawa yung area. So this bolt here is undergoing double shear. Double shear, bakit? Because if you apply a force here, yung area that is under shear stress, it can actually fail or pwede siyang mag-fail in this portion considering the shear stress. So dalawa yung area under shearing stress. So therefore, if the area of this is A, so A yung area ng top, A din yung area ng bottom. Since this is just proportional, so bolt lang yan. Dito, ito yung kinuha nating portion. Ito siya. Itong portion na to is this. Okay? If you push here, okay, apply ka ng force dito, it can experience a shearing stress in this portion, nasa gilid niya. Okay? So, the stress is equal to force over area. In this case, ang area natin is dalawa. So, double shear yan. Okay? That is undergoing double shear. So, yung area natin is the times 2 natin. So, S is equal to force over 2 times the area. Okay, yung 2 dito, guys, depende yan kung yung ating material is undergoing double shear. So, in terms of analysis, can see here that is undergoing double shear in this portion and in this portion. So, yung hinahanap natin dito, guys, what is the smallest diameter? Ano yung smallest diameter ng bolt? So that it can withstand a force of 400 kilonewtons considering na yung bolt material natin, ang kanyang shearing strength is 300 megapascal. Ibig sabihin, ano yung diameter para hindi mag-fail? Okay, para hindi masira yung material natin considering na mag-apply tayo ng 400 kilonewtons. So based on this analysis, if you push here, the pin here or yung ating bolt will experience a shearing stress in this portion, yung nasa gilid. So yung area natin is, since circle lang yan, circle lang siya, so pi diameter squared all over 4. So pi d squared all over 4 if you are in terms of diameter, or pi r squared if you are in terms of radius. So mostly sa mga problem, ang given natin is the diameter. So diameter yung gagamitin natin. So S is equal to F all over 2 times pi d squared all over 4. So 2 times dahil, again, this is undergoing double shear based on this analysis. So we have here, so stress natin is equal to force all over. So cancel na yung 2 dito. So this becomes pi d squared all over 2. Okay, then times 2 natin, times 2 dito. So simplify lang. So times 2 sa numerator, times 2 sa denominator para makancel yung 2 dito. So this becomes 2f all over pi d squared. So simplify lang natin. So this becomes, so pi d squared is equal to 2f. Divide natin both sides by s. Then again, divide both sides by pi. So d squared equals 2f all over pi s. Then we get the square root to find d. So this is d equals, so the square root of 2f all over pi s. Okay, so the square root of 2. Ano yung f natin from the problem? So that is 400 kilonewtons. So this is 400 kilonewtons. So this is pi times s. So our s here from the problem is 300 megapascal. So i-convert natin. So this is 300 megapascal. Then i-convert natin siya. So d equals, so this is the square root of, so 2 times 400 kilonewtons. So this is all over pi. Convert natin to 2 kilopascal. So 300 megapascal times, we have here ang conversion natin. So 1000 kilopascal, this is just equal to 1 megapascal. So since na ang kilo is 1000 din, so 1000 times 1000, that is 1 million. So that is megapascal. Then we have this kilopascal natin, equivalent unit niya is 1 kilonewton per square meter. So that is 1 kilopascal. So mag-cancel na yung kilopascal here. Megapascal will cancel here. So mag-cancel na yung kilopascal here, yung megapascal here, and yung kilonewton dito, mag-cancel. Okay? Then yung meter squared natin dito is mapupunta siya doon sa taas to simplify. Then this becomes, so d equals, so square root ng square meter, so this is in terms of meter. So you just input this in your calculator. So yung diameter natin guys here is 0.29, so 0.0291, okay, meters. In terms of millimeter guys, so this is equal to 29, okay, this is 29.1 mm. So just multiply by 1000 for conversion. So the diameter, okay, yung diameter ng ating bolt, okay, the diameter of the bolt must be 29.1 mm so that it can withstand a force of 400 kilonewtons considering na ang strength ng bolt natin is 300 megapascal. If the diameter of the bolt is less than this value and you have these parameters, surely this bolt here will actually fail. Okay? This is the purpose, that's why this is also included sa mga mechanical engineering. This is included in your machine design. Okay? We are required to find here the smallest diameter. Once your diameter drop, example, let's say 28, okay, 28 yung na-manufacture natin na diameter. Considering these parameters, this bolt here will actually fail. It will break. Therefore, the material is not well designed since it is not the smallest diameter based on your forces and the strength of your materials. Okay? That's it for today's video guys. I hope that you have learned from this topic. If you're new to this channel, just click the subscribe button and the notification bell so that you'll get notified sa mga future videos natin just like this one. Okay? Thank you future engineers for watching this video and I hope that you hit that subscribe button. See you guys. Stay safe and God bless you all.